So I have a very simple chatbot like app here. If I send messages to it, it will respond. I can ask various type of questions like how is the weather, and it will respond. Now in this video we will take this simple Flask chatbot that calls an LLM, and we will add real observability step by step. And I'm not talking about just logs. I mean tracing, latency, metrics, token usage, error tracking, saving request and response artifacts, so we can debug issues like slow responses and random failures. So I hope you are excited for this video. I have set up most of the code already so that I don't spend time on setting up the chatbot. Chatbot is ready. We will just be first of all reviewing the chatbot functionality, chatbot code, so that you understand what we are going into. So it's a simple Flask based application. Here we have two routes. One is home and another one is for handling the response. Now this route takes care of the OpenAI calling, and this home route takes care of the rendering of index.html. Here in the index.html I've got simple div setup. You can see we have got this app and we have got history. This history div would hold the historical conversation, and this sand will hold the input and the button. Okay, and when we click the button, this handle click is going to handle the calling of this API. Now the way it works is we create some bunch of variables for message and history, and we store the context using this message previous messages. And after each click we basically create these JSON like structure, and we push this into previous message. And when we are so after that we append the history, and then after appending the history we are just fetching the response which exists here. And while fetching the response we are passing the user's message and the context. In fact, user's message is not even required. We will be using the context to basically call the API. So you can see here we are getting that context value from the data that we receive from the API request, and we try to call the API. So this is how the current chatbot looks like. It's a very simplistic chatbot. The idea was to show you how you can add observability within an existing application. Now let's talk about the baseline problem that we have. Okay, the baseline problem is we don't have any visibility. Visibility into what? Suppose I send a message. Okay, I send a message, and suddenly those responses are very slow. Okay, so right now our app is working, but if it becomes maybe slow or fails in production, we have no idea. Now why it is happening? Maybe the LLM is slow. Was our app code slow, or was it because of some exception? We don't have any idea. This is exactly where observability exists. So we can answer what happened very quickly. Okay. All right. So how are we going to proceed with it? Let's first of all open the application code. So what is the first thing that we want to do? We want to add a request ID for correlation, so that each request can be tracked. Okay, so every user message gets a unique user ID, not user ID but request ID, so you can find that exact trace or run later. Now how are we going to do that? The first rule of observability is correlation. That is correlation with, so your responses have to be correlated somewhere. Okay, so if a user says my request failed, you need one ID that connects browser to the backend, and by backend will be connected to the LLM call, and LLM call will be connected to logs and traces. So we will add a request ID and return it to the front end. That is the idea. So let's do that. So first of all, we will be importing a package called UUID. Now this UUID basically gets us some unique identification. So we'll be doing that. So inside the response, what we can do is we can do something like request ID is equal to what we need to do is we need to get a request dot headers dot get, and inside here I will say x request id, and if it is not present I can say something like stir uuid dot uuid4. Okay, so I just get a id and I try to extract it from this request. Okay, now I need to return it. Where I can return it here, right? So right now I'm sending the assistant sending the message with only one key, so I will also add a request id, and here I can have a request id parameter that I am generating here. So the idea is that it will try to extract it first from headers. If it is not able to find it, it will just create one. So if it returns, if this get operation returns none, it will just set it, and then we are sending it back. Now what do we need to change in the front end? So if I go inside this this our index.html, in the index.html, now I need to basically uh, pass a request id. So how can I do that? So to be able to do that, what I can do is I can generate a random id here also. So I can use something like a crypto library. Okay, so now what we need to do is after adding this into Flask app.py, next step would be to send this request ID from our front end. So for that we can use crypto package in the JavaScript. So I can do something like crypto dot random uuid, and then I can save this in a request id variable. Okay, so after we save this, what we need to do is we need to okay, sorry, in the I need to define it per session, per request. So I will just um, clear this and I will create this variable here. After we have the request id, what we need to do is we need to create a header key called x request id, and I can pass this request id here. Okay, after this step, what we can do is within this, then when I process the data, what I can do is I can process the text. So basically right now I'm just passing this as assistant message, but I'm not passing any request id here. So I can also have a request id embedded in between. Okay, so in the assistant element dot inner html, what I can do is within here I can create a simple I can embed a simple html tag called small. Okay, and within here I can have the request id, and I can pass dollar here, and I can pass request id here. Okay, after this step is over, now what we will have is we will have this request id for every response. So every response comes with request id, and we would want this request id to be used somewhere. But first let us see how it looks like in the dashboard, in the app. So hey, let's send the message. So the response comes with a request id. Now let's pass some different message. Maybe what is the capital, of France? Okay, and you see this request id is different than this request id. So each response comes with a unique request id. Now we want to go to this 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 like this server code again. Now what we have to do is we need to install MLflow and all I have already installed. So you can check out my other videos where I showed the setup of MLflow and other packages. So what I can do is I can go ahead and uh, start the MLflow server. So what I can do is I can do something like MLflow server. Okay. So it's saying the port is already in use. So what I can do is I can specify port here, maybe 5001. Now it should run, and let's navigate to the UI 127.1. So now you can see we have got the MLflow UI, we have got experiments, we have got models, we have got prompts and AI gateways. Currently no experiments exist. We'll be doing that in a moment. So now what we want to do is we want to create our first monitoring signal, and that is latency. So the idea is that we want to log the latency total, essentially total request time and latency for the LLM. Okay, so what we want to do is we want to basically track the latency of the model. Sorry, not the model, but the request. So how can we set that up? So what we have to do is within our server, we have to import the MLflow, and after importing it, we can, so now after importing this MLflow, we need to set the experiment. Okay. We can either get these details like experiment name and MLflow tracking URI from either environment variables, or we can set them manually. So what I can do is I can do something like set experiment here, and here in the experiment what I can do is I can name it whatever I want. I will name it maybe something like Flask chatbot observability. Okay, so this is the experiment that we have. And how do we measure the total request time? So I have already imported the time module. Here what I can do is I can do something like start time, and I can do something like time dot time, and after the request ends, what I can do is I can do something like uh, end is equal to time dot time, and after this we can log these metrics. So we can do something like MLflow dot start run, and within here I can do something like, one second, MLflow, sorry, in the start run I need to pass with the start run I need to start with this as start run. Now MLflow dot log metric, sorry, and within log metric I will name it as latency total s, or maybe total, and I will pass here and minus start, or maybe we can do something like total latency. We can define a variable called total latency and minus start. Total latency. Okay, so I will log this total latency here, and we can log. So usually in production systems you can log total request time, because in production scenarios you won't be just making one LLM call, you will be having some database calls, some Cosmos DB or maybe Dynamo DB calls. So you would want to log all of that, but let me show you this in action, okay, quickly. So I will just refresh this. Okay, now let me also refresh this quickly, but before okay, so before this let's send some requests. So what I will do is, let me see if my server is up and running. Yes. So I will say, hey, let's wake the LLM up. What is the weather? Let me see. Okay, I think I got some error. What is the error about? It's saying node name, the above node name is not found. What is this error about? Hmm, let's see. I think it is not able to find something, although our server is running. Yes. And do we have ML runs? Yes, we have the ML runs. Why exactly it is failing? What it is not able to find? It's saying node name or surname not no.